Hey everybody, this is Alex Merced from alexmercedcoder.com with some more lessons on programming in Swift. So we're going to go over some collections and some functions. So first let's talk about collections real quick. So collections just means how can you store more than one piece of data in one variable. So there's three different main ways of doing it. There's arrays. So the way you would declare an array is you have to again do var my array, and then arrays are symbolized by a square bracket. So you would just do a square bracket and say, um, 1, 2, 3, 4. So this automatically tells Swift that you have created an array because they see that you've created an array, and the array is of 4 spots. Okay, and if I wanted to print that array, I could print my array. And what if I only wanted to print one item in the array? Well, it's indexed. So it's basically the first spot is 0. So really what I want to do is print my array 0. And see, first it prints the whole array, and then it just prints the first item in the array when I print index 0. So that's how you call the different items in an array. Generally, there's a bunch of array functions in every language, so that's going to be something very important for you to go out there and research. I highly recommend doing that. Those are usually oftentimes, I know when I'm working like JavaScript and Python, those are some of the functions that I end up using the most because you work a lot with arrays and strings and whatnot. So learning the methods that are built in for working with arrays and strings is going to be very valuable in any language. Okay, but here I'm just giving you the core concepts. I'll let you guys do the extra research as part of the learning process. Part of becoming a good programmer, it's not just taking good instruction, but being able to go out there and learn the rest yourself and add to your repertoire of knowledge and practice. It's a little harder at first, but as you learn that skill, you'll be a much more effective programmer for it. Okay, so var my array. Now the second one is called a set. Okay. Now the way a set works is pretty much everything is, except you're going to be doing this in boop, 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 boop. You're going to be doing this in curly brackets, except one big difference is that you have to declare that it's a set. So you're going to say my set, and then you put your curly brackets. Now the difference between a set and an array is that a set cannot have duplicate values. So I couldn't have like 4 twice. Well, in my array, I could have 2 spots to have 4 in it. That's fine, because an array is not assuming that you're looking to just have one of each type of data. It's just saying if you're collecting a list of names, people might have the same name. So an array says that's fine. But maybe you're collecting a list of serial numbers and you want to make sure that there's no duplicates and make sure that it throws you an error if there are duplicates. Then a set might be your preferred data type, because if for some reason a duplicate ends up in there, your program will throw an error and that gives you a sign that something's wrong. And oftentimes errors are your friend. Okay, errors, people get frustrated with things that throw them errors, and they but the idea is that by errors being thrown at you, you're more likely going to end up have a program or finish with a result that does what you want it to do, instead of having a program that just runs despite it screwing things up. Okay, so in that case of a serial number, I would prefer to have it use a set and have this thing error out because something got duplicated in the data set and now I know, versus using an array where it'll just be like, oh, okay, another piece of data, great. And I don't realize that it may be entering the same data multiple times because it's not throwing me back an error. So that's why there are sort of limited control data sets, because in the situations where you need certain controls in place, it puts those controls in place to get you the errors you need to make sure that your program is working. Okay, and the last one is a dictionary. Let's go to. Now, dictionaries are basically just key value pairs. These exist in all programming languages. They can be referred to as dictionaries, as maps, as objects, depending on the programming language, but they all serve the same function. Instead of me looking at my variables as a cubbyhole with a number and an index, I'm looking at it with a title. So in this case, say my dictionary is basically going to equal, and it's going to be square brackets again, always square brackets for Swift. Okay, and then basically you always have, let's say, name. It's going to be my key. And then you put a colon, and you put your value. So my name is Alex Merced. Then you put a comma. My age is 34 at the recording of this video. And now I have my value, and I can call my values by calling the name. Okay, so I could be like, let's print my dictionary colon name. And I should print my name. Oh, we got some errors to see here. Var my date. Heterogeneous collection literal could only be inferred to string any and any explicit type annotation. Yeah, no, I didn't want to specify the type, so that's fine. Let's see here. Where is the error? Oh, use when declared type set. Did I forget to my set not? Oh, I think I need to put can't have a space there. On that. To clear those errors, one, set had to be capitalized. So when I declared my set, I had to make sure that was capitalized. Again, caps matter. And then two, that when it comes to a dictionary, all the values and all the keys have to be the same type. So all the keys can be strings, but then all the values have to be the same type. So since I had Alex Merced, the first value as a string, I need to have the age as a string as well. So these all the values have to be the same type, all the keys have to be the same type. So I had to make 34 a string. So then it works. So again, it printed out that entry inside my dictionary, Alex Merced. Okie dokie. Okay, so continuing on, we'll talk about functions. So what a function is sort of a cluster of code that you can call whenever you want. So you give it a name, and whenever you need to use it, you just call it, and it runs that code again. This way you don't have to type the same code over and over again. It's a programming concept called dry. Don't repeat yourself. Seems pretty straightforward, right? If you're going to write something over and over again, you might as well not write it over and over again. So the way this works is you're going to use the keyword func. That means I'm going to declare a function, and then you would name your function. We'll call it, hi you. Okay? Then what you do is you declare your parameters. So this is the kind of information that whoever uses the function will put into the function for the function to do whatever it wants to do. You could put nothing. You don't have to have parameters. So I could just leave that as an empty parentheses. But if I do want to call parameters, so we'll say, two people are saying hi to each other. What's interesting in Swift is you actually have two names for your parameters, an external and internal name. So the way it would work is I would write to, that would be the external name, which this is kind of a different than most other programming languages. Then you'd have your normal internal name. So we'll call that first name or first person. And then you have to declare the type. So we want a string. Okay. And then we'll do our second variable, which is from, so second person, and that will also be a string. Now the purpose of this external name is just to make it when you write the function, it just speaks a little bit more like a sentence. So you don't have to do it. You could just do first string, second string. That would be fine. As long as you have some way to call the variable internally. So basically, if you don't name two names for the variable, so to first, if I just did first colon string, it would just assume that first is the internal name and have no external value. So the way we'll do this is we'll say print, okay, first plus says hello to, actually it should be second because it's from, second hello to plus first. This is called string concatenation, where I'm basically connecting a series of strings together that are stored in variables by using the plus sign. Okay, so now if I call this function, so if I wanted to use this function in my code, I can just say, hi, you. I have to declare my first variable, but since I named an external name, I have to use it. So I have to be like, to Bob from Steve. Okay, so I have to use, that's what the external variable name is for. It's just so that way when I read it, that tells me a little bit more about how the results should look like. So I know that we're going to be sending it to Bob, and then the hello is coming from Steve. Do I have to do that? No. Again, I can exclude the external name, but if you think it'll make your code, but once you include it, you have to use it. So I have to put the to in the from once I use it. And then I can call this multiple times. So IU, Control C. Well, first let's make sure it works, and then we'll call it multiple times. Steve says hello to Bob. Let's call it 2 more times, except now we'll say Joe to Bob, and then from Steve to Joe. Okay, and I run that, and see it prints out the same thing 3 times, and I don't have to type the says hello to part over and over again. I can just take my 2 names, and it just figures it out for me. Okay, and you can even take that a step further. You could store the names in an array, and then have a loop that loops, puts the name, and then puts the name as the parameters, so that way you only have to basically create one loop that'll go through every possibility for you. So, when you start compounding all these different ideas, you can really see how you can get a lot of mileage out of a few lines of code if you use your tools right. Because you collect all your names in an array, you use a loop that then just keeps repeating different combinations until you've printed out a whole bunch of combinations of this function. Okay, so that's pretty cool. Okay, so that's what a function does. Okay, and you can do functions with numbers. Now, oftentimes you may want a function to return a value. So if you do, then you would just have at the end of the function return, and then whatever it returns. The benefit of a return value is just that way when the function runs, it gives you back a number that you could use as part of an equation or use in another function. Right now, this function doesn't return anything. Okay, so if I were to do this, print, well, let me get rid of the word return while I'm at it. Print that function call. I mean, this function call will still print to the screen because that's part of the function itself, but the actual print won't do anything because there's no value returned from the function. So say it just prints an empty thing because the function's not giving anything back. The function's doing something, but it's not giving anything back. That's what the return value does. So if I were to do return, let's see what happens if I just do return 5. I return the number 5 for whatever reason. Just do it. Okay, or unexpected non-void return. Value in void function. Yeah, I had to specify the return type here. What that means is that I'm actually supposed to at the top specify what kind of value it's going to be returned. To state what your return value is going to be, what you have to do is right after you declare your parameters, you're going to add this little piece of code here. There's a little arrow saying this function will return an integer. And again, the types of variables, int, double, string, boolean, they're all uppercase. So keep that in my own work if it's lowercase. Okay, so I'm saying I'm going to return an int, so now it will return 5. So if I run the code again, see, Steve says hello to Bob because it's running the function in there, and then the value, that function then finishes and returns 5 to the print function, which then prints 5. That's what's important about like returning a value, because it allows you to kind of pass information somewhere else to be used by another function. So that's why you would care about a return value. So kind of cap this off, we're going to talk about classes. Classes are a way you create objects, which is part of what's called object-oriented programming. The idea is you need to define sort of the different concepts and ideas in your program. I always like to use the animal dog analogy because basically there's an idea of animal, okay, and so the class is the noun that is animal, Now, animals have certain characteristics. These are going to be the properties or variables stored within the animal noun, the object. But the animal can do certain things. It can take certain actions. It can verb, and those verbs are functions. Functions are things that you do, okay, which are referred to as methods of the class. So the question then becomes, how do you declare a class in Swift? Okay, in most languages it's generally the same type of context, but let's talk about it. So, for example, let's say we want to create a class that's animal. Class, generally class names are capitalized, and then basically anything within these curly brackets defines that class animal. In this case, what we want to do is we want to declare some variables. So let's say the animal has a name. So var name string var age int. Okay, so we have some variables. We want to actually set a value for this string and age variable. You may want to have it given when the animal gets created. So to do that, you need to create what's called a constructor. A constructor function is a function that gets called once when you create a class. So whenever I create an animal, this function will be called, do a thing, and never do it again. Okay, it constructs the class. And you can decide what that means. So usually you would do that with this init function. So it would be init, you choose your parameters. So we'll say, name and age, so n and a. Okay, and again, n is going to be a string. A is going to be an int. Okay. Oh, we got to capitalize that. Then I put my curly brackets to determine what happens inside the function. And basically all it's going to do is assign my variables. So it's just going to say name equals n, age equals a. Cool. Okay. Bum, 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 bum. So that's that. So age, and then that function's done. Okay, and I can create other functions as well. Again, these would be methods of the class. So this could be something like we'll say sound. The animal makes a sound, and no parameters are taken. Okay, let me just declare that as a func sound, and all it does is print animal makes a sound. Okay, and actually what we'll do, space, we're going to say name makes a sound. So that way the animal's name is in there. Okay, cool. So there's our class. How will we create one? So let's try it out. So let's say we create a new animal called Sparky. And we have to declare like a variable. So you have to be like variable Sparky equals a animal. Okay, and then again we take two parameters in our constructor. So I need to put the name. So Sparky is the name. And age, we'll say 3 years old. Now let's see if we can print. Oh, let's see if Sparky will make a sound. So Sparky, the way usually if you're calling a class's function is like Sparky, the individual instance of the class, dot sound. And then the two parentheses to show that it's a function call, and let's see what happens. Okay, we got some errors we got to clean up. So let's see here, expected declaration init. So that's supposed to be func init. Let me check. No, that looks right. Class size. So yep, we got that. and end string, whatnot. That's all good. I think init is supposed to be lowercase actually. That's so let's try that. Okay, that reduced some of the errors. And a Swift, a missing argument labels, and a in call variable Sparky. A Swift missing argument labels. Oh, so it wants me to label it. Okay, so let's try that. So n is Sparky, a is 3. Okay, that works. So basically what you have to do is you have to actually put in the labels when you declare the new thing. Okay, so name Sparky age 3. Okay, and then Sparky makes a sound. Cool. Okay, so just so you see what we fixed there is that init needed to be lowercase, and then when you declare the initializer, when you create a new animal, you actually have to put those little labels on there. Okay, so yeah, so basically it's treating them automatically like external labels. So just keep that in mind. That's all fine and good, but you know, Sparky makes a sound isn't very descriptive. What if I wanted it to be, I think Sparky's a dog, and I would like Sparky to bark? I mean, I could go in the initializer and define a new variable called sound, and then concatenate that into the sound function. Well, what if I really wanted bark to be a sole separate function? I'm not going to create a function for every type of sound in every animal. That just seems not useful. But I don't want to have to retype all the stuff I already did for animal. What I can do is you can create a new class and inherit from animal. So you'd create a new class, and it would be called dog, and then you put semicolon animal, which means that it's a new class called dog that inherits from animal. So it keeps everything that animal already has, so I don't have to change any of it. All I can do is just add the one function I want to add, func bark. And then just add that function. Or actually, I can even just override the existing function sound, because there's no need for the sound function. I'm just going to say, hey, when it's a dog, it makes a different sound. Okay? See, and that's called function overriding. You're basically overriding the function when you're using that subclass. In this case, we'll just say barks. Save. Well, we don't have to save it from here in REPL, it automatically saves. So now if we run, so now we're going to make, instead of declaring Sparky as an animal, we're going to declare Sparky as a dog. But again, it's going to take the same constructor from before, from when we declared animal, because it's inheriting from the animal class. Okay. Except now, it's going to run the version of the sound function from dog. Let's see here. Overriding declaration requires an override keyword. Okay, so I have to explicitly say override. So let's see here. Override. These are actually pretty good. These are pretty good error descriptions. I like that. It actually tells you like where stuff is missing and exactly what's missing. A lot of times you don't get as descriptive error descriptions from different languages. Okay, func override sound. Let's see if that does the trick. Join. Some camel case. So it wants me to do this. Override sound. I don't think that's the answer, but let's find out. Oh, nope, that makes it a different function. So let me just double check. So the word override is supposed to actually go before the word func. So you're saying override function sound. So that should work now. Override func sound. Wait a minute, I spelled override wrong. Override func. Is sound spelled the same? Oh, capitals. Capitals, capitals, capitals. There we go. Because the original sound is lowercase. Cool. Now Sparky bark. So notice I didn't change the bottom code. This still was Sparky calling the sound function. But since I overrode it, and again I had to use the override keyword before the word function, in the subclass, it allowed me to call that function instead. So you can create sort of like a template mother class that kind of defines the basics that are going to be in common with among all your different types of objects, and then declare subclasses with the minor differences in between, which helps reduce the amount of code you're duplicating. And again, that's always the goal. The idea is to write less code, so that way your code is more explicit, easier to read, and easier to debug. It's not necessarily so much about speed, because again, this code is going to get interpreted or compiled. So the actual interpreted version or compiled version may not necessarily be as succinct as your overall code, but the bigger concern is like your code. You have to go back there and make changes every once in a while. You want to make sure that you write it in a nice, succinct way, where if you need to make changes to it, you're making as few changes as possible, so there's less chance that you break the code. So that's a good overview of Swift in these two videos. So hopefully this gives you a nice core. Now again, if you're not familiar with Swift, it's mainly used for building iPhone applications, but it can be used in other ways. It is a general purpose programming language. There are frameworks for using it for creating websites and web applications. There are frameworks for using it in other use cases, even though it is mainly used for creating iPhone applications. But hopefully this gave you a nice overview. Enjoy. I'll see you guys later on. This is Alex Merced from alexmercedcoder.com. So go practice Swift and go learn more features. So go look up how to edit arrays, strings, and do some other cool stuff in Swift. Thank you very much.